Hi, in this video on design of concrete structures, we will discuss about the type 2 and type 3 type of numerical problems. In the last video, I discussed about the various steps involved in solving this problem and also one problem that's the simplest form of it, and in this video, we'll continue with it. We'll take up this problem which says that we have to find the resisting moment and also we have to redesign if necessary. In this question, what we'll do is, as step 1, we'll be writing on all the required details at the breadth, and here the effective depth is given, it's specified as 400 mm, we don't have the overall depth here, and so I'm not drawing the figure also. So the Fy is given as 415 and FCK is 20 MPa, and AST we can find out as pi by 4 into d square, the diameter is 16 mm bar, 4 number of bars is given, so we use into 4, multiply by 4 and get 804.24 mm square. So this is the first step, and the second step we will find out the actual neutral axis depth and the limiting neutral axis depth. For that we use page number 96 annex G of IS 456. We use this equation and substitute it directly. All the values are here. Substituted we will get 0.504 as the actual neutral axis depth. And the limiting value is given in page number 70 based on the different type of steel used. Based on the yield strength of steel, XU max by D is 0.48 for Fe415 steel. So in this case, we find out that this value is greater than this value. So XU by D is greater than XU max by D. This is 0.48 and this is 0.5450. So in that case, the section is an over reinforced section. We know that in case of an over reinforced section, we cannot use this for design, we have to redesign. So to redesign, we need to find out the maximum moment it can resist. So mu, for such a over reinforced section, we use mu is equal to mu limit, because it's the maximum value it can take. That is, the limiting value is the maximum value. Okay, in this case, or even the same cases are also used in case of a balanced section also. Same equation we can use. Okay, mu is equal to this equation given in page number 96 in annex G, and substituting all the values in here, that is XU max by D, we have the value of XU max by D is 0.48. We can substitute over here and here. FCK and DD, everything we know. Substituting we get 88.29 Newton mm as the resisting moment value for this over reinforced section. That's the maximum value it can take. So in IS 456 page number 96, it suggests that an over reinforced section should always be redesigned. Okay, it should not be used in the proper sense because it doesn't give any warning before failure. Because all the strength is, all the tension loads are taken up by the steel, and the concrete it fails. Because the steel is not yielding, the concrete fails in compression without any warning. It will be a brittle failure. It's not good for us. So what we do is we will redesign. For this is step 3, or the redesign. Only if it is asked in the question we have to do it. Otherwise we can stop over here. And for the redesign part, since the XU by D is greater than XU max by D, what we do is we limit the XU value to XU max. That's the maximum value it can take is 0.48. And we limit this value to this value, that is XU max by D is the maximum value it can take. So we find out XU max by D value, because 0.7885 AST into 0.50 CKBD, this is the equation that is given in the page number 96. So what we do is, over here the XU max by D we know the value. What's the value? 0.48, we can substitute directly. Instead of XU by D, we are using XU max by D. That's the difference in this step. Okay, I hope you understand that. Why are we doing this? Because XU by D, the value is very very high than XU max by D. We can't have that because this is the maximum limiting value this structure can take. 200 by 400 this steel can take. So that is why we are limiting it to XU max by D, and the value is 0.48. For this particular value, what we find out is the area of steel that should be provided. Over here, the area of steel was 804.24. That's what we substituted here. We can't use that because this is over reinforcing this structure. 200 by 400, that beam. This, whatever reinforcement that is given, it is over reinforcing that member. So what we do is we find out the new AST. Substituting the value, we get the new AST as 765.76 mm square. This is the redesign part for we can use this AST for this particular beam. And in the coming videos, in the next module maybe, I will be discussing how to convert this AST value into that particular, what's the size of the diameter of the members or the reinforcing steel that should be used, and also the number of members that should be given. That we can find out from the AST value. We will discuss that later because that's not important this for this particular question. So this is the final answer for your question. So this is the type 2. And also now we will discuss another type of question, that is regarding when a load is acting on the structure and what is the maximum load, what is the ultimate load that the structure can take. That will be the next part of this video. Okay. Now let us discuss the third type of question. In this question, what we do is we have to find the particular load or the ultimate load that the section can take. So we will discuss this question here. In this question, what is important is given a beam of 200 by 400, similar size as last question, and Fy and Fck everything is given. And in this question, what we have to do is we have to find the load that can be safely carried, the ultimate UDL which the beam can carry safely over a span of 5 meter. And also given M20 concrete and Fe415 steel. And in this particular case, what we will do is step 1 is write on all the parts here. Everything is here, and AST we can find out by 4 into 16 is the diameter of the bar given, and there are 3 number of bars, therefore 603.18 is the area of steel for this particular section. In step 2, the same procedure is repeated. Actual depth of neutral axis you have to find out from page number 96 equation. Thus, from the last question, only changes the AST value is changed, everything is remaining same. So is 0.378, and the limiting depth of Fe415 is 0.48. You must be able to remember these values because we always using Fe415. Rarely we use Fe500. Fe250 we will never use. So that is what we are using, Fe415 0.48. So here the section is under reinforced because this value X2 by D actual value is less than 0.48. So it is an under reinforced section. For an under reinforced section, what usually we do is we find the resisting moment as equal to or less than the limiting moment, and we use the equation 0.87 into something that kind of equation, page number 96. But what we do here is we equate mu is equal to mu limit. Why? Because in this question what we have to find out is the ultimate moment or the maximum load that the section can take. That's what we have to find out. So while finding the moment, we have to use the ultimate moment equation, that is the limiting moment equation. That's the only difference in this type of question. Only in this type of question, whenever we are finding the ultimate moment, what we do is, whenever we find the resisting moment, what we do is we equate it to the ultimate moment, because in the question they are asked to find the ultimate UDL value. That's the maximum value is taken up only when there is a maximum moment. Maximum moment happens only when the load is maximum, or if the moment is maximum, the load should be maximum. That is the idea behind it. So we use this equation, and XU by D we use XU max by D, the maximum value of neutral axis. Everything will be in the maximum because we have to find ultimate. That value, that term is very important. In this question, if it is asked just find the UDL that can act on this, then we can use a normal case. Depending on the question, you have to change it. So normally, if it is asked like this, you have to equate to the ultimate moment. Substituting every values, we get the ultimate moment as, or the maximum limiting moment as 88.29 kN meter. So this is the second step. The third step, that is third part, the question is asked find the load, ultimate load value. For that thing, we also know we consider a simply supported beam. In a simply supported beam, if a UDL is acting, what's the maximum bending moment? Maximum minimum value is WL square divided by 8, and L is the span. Given that the span is 5 meter, and we have to find the W we have to find as a UDL value. That's it, not the point load, it's a UDL value. So we substitute everything. We substitute the maximum limiting moment here and length 5 meter span here. Then we get the maximum UDL value as 22.25 kN per meter square as the maximum UDL this particular section can take. So hope you understand this question. Everything up to step 2 is same. At the last section of step 2, while finding the moment, we have to use the ultimate moment, because they have asked the ultimate load. Remember that. And using that equation and using this particular equation of maximum minimum on a simply supported beam, you can find out the ultimate UDL acting on this particular section. So that's it about this video. Thank you.